In this video, we are going to see about the non-deterministic finite automata. So the finite automata model that allows 0 or 1 or more transition from a state on the input symbol, it is called non-deterministic finite automata. See, as the finite automata allows more than one transition from the state, so anytime the finite control can be any number of states. And when the choice of next state is made, we can imagine that the duplicate copy of automata are made. And an input string will be accepted by the NFA if at least one path should end with the final state. Okay, we will see one example. Here the design the NFA to accept the string starts with the A and ends with the B. Okay, so what can be an input symbol? AB, then AAB, then AAA, BA, BBB, or AAB, or ABBB. Okay, so these are the possible input symbols here. So how we can draw the state diagram here? So first transition diagram. Okay, so first Q naught is the first initial state. So what is the condition? It should start with the A and end with the B. So what we are doing, the first transition from Q1 to Q0, we are giving the input symbol as a A. Then next it should end with the B. So we can give B. So now it starts with A and starts with B. So in between this A and B, it can have a multiple number of A's and B's. So we can create the A loop here for A and B, and this Q2 can be a final state. Okay, so we can check with this symbol. So here one thing is one path that ends with the final state also. So input symbol A, so the transition will be from Q0 to Q1. The next B, so it will stay in the same state Q1. Again next also B, again it will stay in the same state. Again last B, so one path will go to the final state. Then how will you write the transition table? So the states are Q0, Q1 and Q2, then A and B. So what is Q0 comma A? It is going to the next state Q1. Then what is Q0 comma B? So there is no transition, so it is null. Then what is Q1 comma A? So it is staying in the same state Q1. Then what is Q1 comma B? In the same state Q1 and the Q2. So it is Q1 and Q2. Then Q2 comma A, it is no transition, so it is null. Q2 comma B, no transition, so it is null. Okay, so this is a transition diagram and the table. Next we will see the formal definition for the automata. So it is same as the finite automata. Same as the deterministic finite automata. So it is also having 5 tuples. So first one, Q is a set of state. This next one, sigma is the input alphabet. Delta is a transition function. So if it is Q comma symbol is a P of Q. So where P of Q is a power of set of Q, because it contains more than one transition, so it is a set of Q. Then Q0 is the initial state and F is a set of final states. So we will write the formal definition for this. So first set of states, so it is Q0, Q1 and Q2, and then the input symbol is A and B. Then delta, our initial state is Q0 and final state is Q2. Then how we will write the transition? So where delta is defined as delta of Q0 comma A. So what is Q0 comma A? You can write it from the table. Q0 comma A is Q1. then delta of q0 comma b, so it is null. Then delta of q1 comma a, q1 comma a is q1, so it is q1. Then delta of q1 comma b, so it is q1 comma q2. Then delta of q2 comma a, so there is no transition, so null. Then delta of q2 comma b, also no transition, so it is null. So this is the formal definition, and we will see one more example. So we have to design the DFA that string ends with the B. So what can be a input symbol? So it is AB or ABBB or AAAB. So it should end with the B. Before the B, it can have a multiple number of A's and B's. Okay, so we can take the initial state as a Q0. Okay, Q0 is the initial state. Then the next state I'm taking as a Q1. So what is the constraint? It should end with the B. So Q0, Q1, we can take the input symbol as a B, and Q1 can be a final state. So before this B, we can have a multiple number of A's and B's. So we can create the loop in a state Q0. So here A comma B. So we can check with the symbol A, B. So A, so it will say in the Q0, again A, Q0, again A, Q0. Then input symbol is B. So it will go to the state Q1, and that is a final state. Then one more example. Design the NFA that accepts the string that end with 0, 0. Okay, that accepts the string that end with 0, 0 for the input symbol 0, comma 1. So it should end with 0, 0, but before that we can have a multiple number of zeros and ones. So for example, if the input is 1, 0, 0, 0, so it is accepted. Suppose 1, 0, 1, 0 means it is not accepted because it is not ending with the 0, 0. And one more example, if it is 0, 0, 1, 1, 0, 0, it is also accepted because it ends with the 0, 0. So at the end it should contain 0, 0. Before this 0, 0, it can have a multiple, any combination of zeros and ones. So how we will draw the transition diagram? So Q0 can be a input symbol. Okay, so here one thing, it should end with 0, 0. Before that it can have a multiple number. So what we can do, this is the initial state. In the initial state itself, what we can do, we can create the loop and we can give the transition for 0 and 1. Okay, the next Q1 state, what we can do, we can do the transition for the input symbol 0, and again the state we can consider this is a final state, and that is Q2, and we are passing the symbol 0. So now you can check, so we can check with this symbol. So first is 0, so it will stay in the Q0, again 0, stay in a Q0, again 1 in a Q0, again 1, Q0. Then input symbol is 0, so Q0 to Q1, again 0, Q1 to Q2. So we have reached the final state.